I will now turn to the actual presentation from Saskatchewan Research Council as outlined in Commission Member Document 14 H5.1 and H5.1A. I understand that Mr. Muldoon will make this presentation. Please proceed.
Good morning. My name is Joe Muldoon. I'm the Vice President of Environment at Saskatchewan Research Council. With me today is Ian Wilson. The remediation to my left is Ian Wilson, the remediation manager for the project. To my right is Dr. Alexei Klyashtarin and Chris Reed, to my right behind me, who are the project managers for the Gunnar remediation project. Directly behind me is Hal Sanders, who, as you mentioned, the Assistant Deputy Minister with Saskatchewan Environment, Saskatchewan Economy is here as well. Saskatchewan Research Council, our objective today is to apply for a CNSC license to allow us to proceed forward with the management of the Gunnar remediation project. Dealing first with the purpose of the project, the immediate site safety is being managed through restricted access and community education. Longer-term hazards at Gunnar are being addressed in the context of 3 project objectives. These are focused on eliminating or reducing risks to humans and the environment, applying technically and economically feasible approaches to conduct the remediation itself, and establishing a cost-effective monitoring program that minimizes long-term care and maintenance at the site, which can be very costly due to the remoteness of the site and the fact that it is off the power grid. The Gunnar remediation project is funded 100% through public funds. We are looking for solutions that minimize the risk of having to undertake any major post-remediation work that would require significant mobilization to a remote site. This approach also ensures a smooth transition into the institutional controls program. In terms of its history, the abandoned Gunnar site housed a residential area along with a mine and mill comprising an open pit and underground workings from which uranium ore was mined and subsequently milled on site. The site was operated by the now non-existent Gunnar Mining Limited from 1953 to 1964, and it was left as is with no or little decommissioning. The site is a legacy site and is a liability of the province. The Gunnar mine was operated under different environmental standards than we would expect today. The current environmental state of the site is unacceptable under modern standards, and the province has contracted Saskatchewan Research Council to manage the cleanup of the site. As a result, SRC has been working closely with project partners, regulatory agencies, and northern communities to develop a plan to remediate the site. Between 2010 and 2011, focus had been placed on the abatement and demolition of buildings and structures on the Gunnar site to address public safety concerns in compliance with Commission Order 10-1. With the successful completion of that work, SRC has been focused on gaining the necessary approvals for the remediation plan through the environmental assessment process in parallel with developing licensing documentation for the site. These photos are from Saskatchewan archives and show the site at the start of surface mining activities. That would be the picture on the left. The mill infrastructure to your right included drum filters on the top, acid leach tanks in the middle, and a diesel power plant to the right. SRC has developed plans to address the risks associated with the complex interactions of the major site components or site aspects listed here. The major site risks, as indicated in the 2013 EIS, are 3 separate tailings areas, the flooded pit, waste management, and the waste rock piles. Site safety, environmental protection, and cost effectiveness are our guiding principles for this project. These images show the locations of the major human and ecological risks at the site. You can see the Langley Bay tailings, the Gunnar Central tailings, and the Gunnar Main tailings in the picture to your left. And it gives you an idea in terms of the mine site with the pit in the forefront of that picture. And they're labeled in the picture to the right. The hazards that are present on the site include physical hazards in the form of debris, steep slopes, radiation exposure from the waste rock and tailings areas, chemical contamination as well, some of the formal industrial reagents, those kinds of things. There's also asbestos-containing materials, friable and non-friable, that were dealt with in 2010, but which are currently on site. The purpose of this project is to reduce the risks the site poses in its current state for the health and safety of the public and environment. Remedial planning has focused on a concise list of site aspects for major contaminant source and/or risk areas at the site, including the uranium tailings deposits, the open pit, and the waste rock piles. Specifically, the remediation project objectives and endpoints are the management of the tailings and waste rock piles to reduce the gamma dose rates, minimize contaminant releases to the receiving environment, permanent management of all the waste materials, remediation and contouring for compatibility with the natural surroundings and future use of the site, and taking measures to ensure conventional health and safety. Those is followed. Due to the size and complexity of the site, a systematic remediation approach is being utilized, consisting of the following phases: the environmental assessment, detailed engineering design to follow, then the actual remediation, post-remediation confirmation monitoring, and then moving the project into institutional control long-term monitoring. I'll now turn the presentation over to Ian Wilson, who will provide further details surrounding the remediation project. Ian?
For the record, my name is Ian Wilson. During the EIS process, assessment of remedial options and alternatives for the site were completed. The majority of the analysis have been undertaken with the purpose of a preferred remedial option for the site. However, a responsible authority had identified the difficulty in rationalizing the choice of a single remedial option. For this reason, a decision tree framework was established for each of the primary risk source, i.e. site aspects, including the 3 tailings deposits, miscellaneous site aspects such as the stockpile demolition, debris, contaminated site around this, and mill complex, as well as the waterfront, open pit, and waste rock. Next slide. Development of the decision trees was based on identification of the known risks to human and ecological health by each site aspect. The goal is to identify those areas where further information would be required prior to initiating remedial activities, as compared to those areas where remedial activities could proceed without further analysis, and to provide justification for preferred options. The decision tree framework is a process to select the remediation options and provide information for further options analysis. This slide shows a diagram of the proposed process for evaluating the remediation options developed during the EIS process into a final design ready for operational implementation. Some of the criteria that will be utilized to choose a preferred remedial option will be: does the option meet the project endpoints and guidelines? Is the option economically efficient? Is the option site-specifically implementable? Is there enough characterization data to support preferred option? Next slide. The next slide is an illustration only of a decision tree as taken from the EIS. Without going through any of the detail presented, the decision tree is a graphical analysis of risks to human health and ecological health, physical hazards posed by each site aspect in its immediate source area, intermediate pathways, and receiving environments. Next slide. It is anticipated that most utilization of decision tree frameworks and options analysis will be during the detailed engineering design phase of the project. Here is a very general graphic of the anticipated engineering design process. What is important here is that the process for completing analysis clearly shows that a proposed remediation option provides the most cost-effective solution. Monitoring and follow-up programs are an integral component of the federal and provincial legislation and regulatory framework. Monitoring will ensure compliance with any regulatory requirements and will allow systematic audit of the implementation of the remediation plan, verify the success of the remediation, track contaminant movement on site and into the receiving environment into the future, and allow the site to enter into custodial management, which is we call ICP. ICP. In 2005, Saskatchewan initiated the formal development of an institutional control framework, ICP, for the long-term management of decommissioned mine and mill sites on provincial crown land. In 2007, the province legislated the Reclaimed Industrial Sites Act and a Reclaimed Industrial Sites Regulation to establish and enforce the Institutional Control Program, or ICP. The ICP implements the process for the long-term monitoring and maintenance of sites when mining and milling activities have ended, remediation has been completed and approved, and the process for transfer of the site to provincial responsibility. The two primary components of the ICP are the Institutional Control Registry and the Institutional Control Funds, which are made up of the Monitoring and Maintenance Fund and the Unforeseen Events Fund. Because of the geographic isolation of the site, it is paramount to plan for and manage logistics. Some of the considerations would include heavy equipment materials transport to site. For this to be done, usually there's two routes, either via barge in the summer or ice road in the winter. Moving staff and labor to site. Snow machines, boats, and air are usually our ways, our means of getting these resources to site. I've put a couple pictures of some of the infrastructure that is currently on site. In the middle is the 85-person camp, which composed of modular sleeping trailers, 2 generators, a biodisc water treatment system, treatment plant holding, and laboratory trailer. Primary timeline. In 2014, we have completed the initial licensing process, public procurement to select a remediation design engineer, and begin preliminary remediation engineering design with cost benefit. In 2015, we planned a design engineer to develop field investigation plan to obtain gap information for remediation design, complete engineering design field investigation, design engineer to complete issued for tender remediation design, public procurement to select implementation contractors, and initialize remediation options. In 2016, we plan to mobilize heavy equipment and materials for remediation options on the winter ice road and begin remediation operations. It is critical, both from a geographic, economic, and social aspect, to maintain project momentum by maintaining schedule milestones and timelines. Engagement. SRC understands the importance of engagement with peoples affected by remediation work in this region. SRC will continue to engage the people and communities living in Athabasca Basin at all stages of this project, including the decision tree. SRC currently has committed to and has utilized a community monitoring program during work on its sites. The program consists of hiring Athabasca community members to travel to SRC project sites, observe activities, and speak with workers and report back to Athabasca community leadership and SRC regarding their findings. Some examples of SRC's social engagement in the past are as follows: 107 community meetings, SRC has provided industrial construction training for more than 100 local Athabasca residents for gunner demolition, have developed Homer Yellowknife capacity building opportunity for Fond du Lac Denisovan First Nation. Community representatives directly participated in gunner remedial option development during environmental impact process. Community representatives directly participate in Gunnar and Laredo proposal review evaluations and support of Prince Albert Grand Council, PAGC, traditional knowledge and traditional land use study. SRC will continue to utilize best practices to maximize benefits to Athabasca Basin. Some examples of economic benefits are as follows. To date, 50% local labor utilization for gunner demolition project. Year to date, 52% Athabasca Aboriginal labor utilization on the Laredo remediation project. Year to date, 72% local heavy equipment utilization on the Laredo remediation project, as well as economic partner for PAGC Athabasca Community Training Initiative, direct economic benefits to Athabasca community businesses, indirectly through Athabasca Basin Development Corporation, and economic support of Northern and Aboriginal cultural and sporting events. The SRC and Government of Saskatchewan have made a concerted effort to ensure that ongoing site activities are communicated to residents of the Athabasca region. On average, community meetings have been held 3 times per year within the region. Currently, SRC utilizes multiple means of distributing information to people and communities of the Athabasca, including through First Nations Aboriginal chiefs and community leaders, through PAGC and Métis locals, through community meetings, through Athabasca sector gatherings, through community monitors, through Northern Multimedia, through Dene translations of our documents, and through community site tours. This slide highlights some of the specific information distribution SRC has used in the past, which includes on-site hazard signage in both English and Dene on the top left, various forms of multimedia, which includes Facebook, SRC websites, Twitters and blog, articles in traditional printed media, and clear language Dene summary of the Laredo EIS in the bottom right. The management system is composed of programs that contain various plans that are specific to and coordinate how the work is going to be conducted on site. As part of its CNSC licensing commitment, SRC has developed a management system which consists of 5 major components: environmental protection, safety, training, quality, and communication. The purpose of the environmental protection program is to ensure the protection of the environment during all activities for the Gunnar Site Remediation Project. This program governs the control of remediation activities, including the Environmental Management Plan, the Spill Response Plan, and the Environmental Monitoring Plan. This program and plans will help ensure that the impact from planned activities and potential predicted events will be minimized. Occupational health and safety. The purpose of the Occupational Health and Safety program for the project is to provide site-specific guidance and metrics in support of SRC's corporate occupational health and safety policy and objectives. This program conforms to the Saskatchewan Occupational Health and Safety Act and regulations and includes the Radiation Protection Plan, the Site Security Plan, Emergency Plan, Wildfire Prevention and Preparedness Plan, the Emergency Medical Plan, and the Occupational Health and Safety Plan. Training Plan. The purpose of the training plan is to outline the process that SRC employs to train its employees and contractors for the project. The training program includes the training plan, which outlines how training will be identified, employed, tracked for SRC employees and contractors while working at the site. Quality program. The purpose of the quality to outline the process that governs how the SRC ensures quality work for the project. The quality program covers the framework which establishes the process required to ensure that SRC continuously monitors its performance and fosters a high-quality product. The quality includes the quality assurance plan, the corrective action plan, the management of change plan, and the document control plan. Finally, communication plan. The purpose of the communication program is to outline the process that SRC employs to communicate with the project interested third parties. The program includes the communication plan, which outlines how internal and external communication is conducted and recorded, as well as the general community and public views, opinions, and concerns related to the site.
Joe Muldoon for the record. In conclusion, SRC is requesting a license phase 1 from Canadian Nuclear Safety Commission to proceed with remediation of the site. SRC has set an ambitious schedule to implement final assessment, engineering design, and remediation activities, and is anxious to get going when we can. Thank you. That concludes our presentation.
Thank you.